Good morning friends. In this video I am going to explain you about friction. First of all, we should know what is meant by friction. Friction means the force which opposes the movement or the tendency of movement is called frictional force or simply friction. Let us draw a diagram. A block is placed on a rough surface the block is having some weight W, and the rough surface develops a normal reaction force. Let us assume that the body is said to be moving in the forward direction. Means when the block is said to be moving in the forward direction, the frictional force should act opposite to that of motion is nothing but of a friction. In this diagram we can clearly understood that the frictional force should always oppose the actual motion. The block is on a rough inclined plane. By using of this diagram, we are going to solve different problems of friction. So this is the problem which we are going to solve. A block weight is 1000 Newton rests over block B which weighs 2000 Newton as shown in the figure. Block A is tied to wall with a horizontal string. If the coefficient of friction between A and B is 1/4 and between B and floor is 1/2, what should be the value of P to move the block B? If P is horizontal, P acts 30 degrees to horizontal. In this problem, what he is asking that he is asking to solve if P is horizontal and P acts 30 degrees to the horizontal, we need to find the value of P. See, a block weight is 1000 Newton. Here the block given in the diagram is of 1000 Newton. This 1000 Newton block is resting on 2000 Newton block as shown in the figure. Block A, in the problem itself it is telling that the block A is tied to the wall. This is the wall and this is the floor. This A block is tied to the horizontal, is tied with a horizontal string to the vertical wall, and the coefficient of friction between A and B. Coefficient of friction between these two blocks. In between these two blocks, coefficient is represented by mu, and here the coefficient of friction has been given as 1/4. And the coefficient of friction between B and floor. between the block B and the floor, the coefficient of friction has been given 1 by 2, and he is asking that what should be the value of P. Now we need to calculate the force P. We need to calculate the force P and keeping in horizontal as well as in inclined position. Now we are going to solve for the force P. If the diagram has been given like this, we need to isolate, or we need to draw a free body diagrams for block A and block B. First I am drawing free body diagram for block A. For block A means which should be isolated from both the blocks should be isolated. Isolated means should be free, means should be separated. This, as the block is in contact with B, the surface is developing a normal reaction force, and the block A is having some weight, W is equal to 1000 Newton, and here a horizontal string is attached to the vertical wall. As the string is tied with the vertical wall, the frictional force should oppose that horizontal string. By using of this free body diagram, we are resolving the forces of vertical and horizontal forces. Sigma V is equal to 0 means resolving the forces in vertical direction. Forces in vertical direction. What are the forces which we can observe in this free body diagram means vertical forces are nothing but of plus n, as normal force is acting upward, we are taking this as positive. As W is acting downward direction, we are taking this as negative, is equal to 0. Therefore N is equal to W means N is equal to 1000 Newton. We are representing these as 1 W1 F1. We are finding all the four forces here. Okay, we have got the first force N1, and now we are trying for F1, frictional force. F1 is equal to mu1 into N1. Mu is nothing but of coefficient of friction for F1. What is the coefficient of friction which has been given here is mu1 is equal to 1 by 4 and N1 is equal to 1000, means 2 2s are 2 5s are 2 250s are. Therefore we are getting F1 value is equal to 250, and we have got the second force F1 also. And now we are trying for T, means the T is said to be in horizontal forces. So now we are solving the horizontal forces should be equal to 0, means resolving the forces in horizontal direction. That is, what are the forces which are in horizontal direction means plus F1. As F1 is said to be moving in forward direction, we are taking as positive, and as T is said to be move in the negative direction which opposes the motion, means nothing but of T is equal to 0. Therefore F1 is equal to T. Already we have got F1 is equal to 250 Newton. Therefore T is equal to 250 Newton. Hence we have solved for the block A all the forces, and just we are trying for the second block 2000 Newton. That for 2000 Newton also we are having some weight W2, and for this block also we are having some normal force N2, as said in the diagram. P is acting in the forward direction, hence the frictional force should act opposite to this. As the block A is lying on 2000 Newton block also, we need to consider here the normal reaction force on 2000 Newton block also. Now we are trying for the four forces. N2, F2, P and W2. Already W2 has been given as 2000 Newton. Here also in this free body diagram we are solving for N2, F2 and for P. And for P. Now we are resolving the forces vertically. Resolving the forces vertically. What are the forces which are acting in vertical direction? Means plus N2 minus W2 minus N1. Plus N2 minus W2 already has been given as 2000 Newton minus N1, already we know N1 is equal to 1000 Newton is equal to 0. N2 minus 3000 Newton is equal to 0. Therefore N2 is equal to 3000. We have got N2 is equal to 3000 Newton, and now we are solving for F2. We all knows that for calculating frictional force we are having an equation that F2 is equal to mu2 into N2. F2 means already it has been given that mu2 is equal to 1 by 2 into N2 means 3000 is equal to 2 1s are 2, 2 5s are 10, 2 15s are 3000. F2 value is 1500 Newton. F2 value is 1500 Newton. And now for P, we are solving the horizontal forces. For P we are solving the horizontal forces. Sigma H is equal to 0. Horizontal, resolving the forces